All right, so we're moving on to talk about the energy associated with chemical reaction or phase changes. To say this with the whole word, so energy associated with chemical reaction or phase change is quite long. So we just call them an enthalpy, which is a fancy word of the heat of reaction. So enthalpy of reaction or heat of reaction, they are the same thing. So we use a delta H and subscript reaction, RXN right there. Okay, so enthalpy of reaction or the heat of reaction is the energy absorbed or giving off by a chemical reaction per mole of reactant. So it depends on how much reactant you add to it. This is per mole. Okay, so for example, propane gas, so we burn it. It's a combustion reaction. The enthalpy of combustion reaction, propane giving off 2,220 kilojoule of heat per mole propane. That's exothermic process. All right, glucose. Yeah, burn it, same thing, combustion reaction, 1 mole glucose produce that much energy. Which means that if you, so we heat it, so this is a combustion reaction, if we get closer to a combustion reaction, that's why you feel hot, right? This is our exothermic process. On the other hand, so reverse, ammonium nitrate using the ice pack, this is an endothermic process. 1 mole of ammonium nitrate absorb 28.1 kilojoule. So if you get closer to this ammonium nitrate, you feel cold. All right, you will losing heat. And the delta H, this right here, DISS, that's a dissolution or dissolving. Okay. All right, we also have, so this is a phase change. If you want to change phase of 1 mole of ice water to liquid water, of course you have to heat it up. Right, 1 mole, so you need 6.01 kilojoule. But if so, heat it up, so positive, put it like heat up this water, this ice water. But if you want to make liquid water, 1 mole of liquid water back to the ice cube, the process has to release the energy, right? So negative 6.01. So FUS, that's a heat of fusion. The energy required to convert 1 mole of solid substance to the liquid state at its melting point. So right here, there's a melting point. You can convert back and forth, positive, negative, depends on the what you do. Positive go to ice water to liquid water. So negative, liquid water to ice water. Okay. We also have heat of vaporization or enthalpy of vaporization. So converting 1 mole of liquid water to gas at the same temperature. The temperature doesn't change. All right. So you need 40.67 kilojoule. Add heat is in here. Conversely, if you want to convert the gas back to the liquid, so this guy have to release 40.67 kilojoule. Same thing. Okay. So the heat of vaporization. We also have, so this one go back to heat of dissolution we mentioned before. So the energy required to dissolve 1 mole of solid substance in a solvent. Okay, it could be solvent, it could be any type of solvent. So dissolve potassium hydroxide, negative. Right? So that's so the solution gets hot. But ammonium chloride, ammonium nitrate, they use in a cold pack, dissolve it, it absorbs heat. So that's why if you touch it, you feel cold. Okay. All right. Next one, we're going to talk about how to determine the enthalpy of this reaction or the heat of reaction. Okay.